to get going?
I am ready. Good morning.
Excellent. Good morning and welcome to Monday Morning Gasoline. This is Mikhail, and with me today is my guest Nathan McMinn. Hi, Nathan.
Good morning.
You're the CTO of Conserv, which does environmental monitoring for museums and other locations. And yeah, thank you for waking up early. I noticed you got a cup of coffee in there.
I'm always up early.
Excellent. So yeah, you know how this started, right? So I got up Monday morning really early, and my favorite podcast stopped being produced. So I decided that we would do something else. And today I'd like to talk to you about your startup. Can you tell us just a little bit about Conserv and kind of you guys started I think in 2017 or 2016.
2018 actually. So let me answer your question with a question. What was the last museum you visited?
It would have to be the Birmingham Museum of Art, and the year was 2018.
Fantastic. So at every museum, library, historic property, even galleries, and a lot of times private collectors, there are people there who are charged with making sure that those things are well cared for, so that those things are still around when your kids and their kids go to the Birmingham Museum of Art and get to see the same objects and get to hear some of the same stories. So one of the best tools they have for doing this is managing the environment things live in, right? Is it the correct temperature? Is everything stable? What does the light exposure look like? Are we going to experience fade on some of these maybe paper or textile artifacts? So we build a complete solution, sensors and software, to help those people do that job.
Very cool. So you build your own hardware, and to me I remember talking to you when you first started, and to me that was always the coolest thing, is that you had to deploy your own hardware, so you had to get it designed, everything from the PCB to, I remember when you guys were first iterating your cases, and you were making them yourself, right, through I guess through Make Birmingham, or I'm not sure exactly where you were making them at the time, but you were iterating through the different cases for your hardware, and it was just really cool to see like physical stuff coming out from a pretty, at the time I think it was just what you had two people, or just the two of you guys working, or
yeah, it was just myself and my co-founder in the beginning, and we looked in the market to see was there a sensor product we could OEM from somebody that would fit our requirements, and the answer pretty quickly became apparent. It was no. So there were a lot of different sensor products out there, but none that had the combination of things that matter to our customers, and none that had the aesthetic that would be acceptable to put on the wall of a museum. A lot of these things look really like scientific measurement equipment, and that's what they are, but they shouldn't look like that, right? I mean, you're putting this stuff up on the wall next to priceless artwork. It needs to look a little bit better. So yeah, we did that. I mean, we sketched out the rough size of the product. We had our PCB designed and built. We figured out where we're going to how big the battery is going to be. And once we had those basic physical constraints, we actually just bought a couple 3D printers and started iterating on the design. I think we went through, I don't know, maybe a dozen, maybe 20 total design iterations before we really felt like we had it right. And what's so cool about the kind of the digital manufacturing chain is those same files that we use for 3D printing with a few tweaks are the same files that we send to our mold maker, who turns that into an injection molded product, right? So I mean, if 3D printing is building stuff up by layers, and your model is the positive, just take that model and invert it, and you've got the negative that you want to use for a mold. So by doing that, we really, when it came time to make the product, we were pretty confident it was going to work.
So is that a special file type that's an industry standard, or is that like CAD-M or something like that, or is that?
Well, for 3D printing, it's just an STL file. But with the tool chains we use, we can take those and we can export that same model as either a step file or a solid file. And that's what pretty much any injection molder in the world can take those and work with them for you.
Very cool. Yeah, I I wouldn't even know where to begin. So, but if let's say I had a crazy idea, which I mean, I have like, about 100 of those before lunchtime. Don't make any of them, but if I had like an idea of I wanted to make a device, and I knew what functions it needed, what sensors I thought it needed, much like I think I have a, like this is a very generic product, right? This is an ESP32 that I like to play with. It's a Lily TT Go, kind of a make yourself watch, runs, I think, Arduino IDE. You can Picto blocks. You can program with a lot of different things on this, but I'm not customizing the hardware. Here, it's all just software. But if I wanted to make like an IoT device, like what would you recommend as to the next founder that wants to go and make an IoT device? How can they bridge this insurmountable void of knowledge? Are there sites? Are there what would you recommend as the pathway to research?
We did all of our prototyping with Arduino. Like a lot of people do, right? I mean, maybe it was a teaching toy when it first came out, but the number of microcontrollers it supports, the number of prototyping boards out there it supports, it's become such a huge ecosystem that for somebody who maybe isn't a double E, and maybe their C isn't quite the strongest, short. Well, no, I'm talking about myself. It's the shortest path to a working prototype. You can also do similar stuff with like ARM embed if that's your thing. But definitely just grab some dev boards and prototype several different things before you commit to building any one thing. We went through, I don't know, probably 6 or 7 breadboard prototypes before we settled on the chips that we wanted to use. And by the time we made that decision, right, we had already taken these prototypes out to the field. I mean, our first prototype was literally a developer board stuffed into an outdoor conduit box. I wish I had one here, right? But it was about this big, chunky, ugly plastic thing, stuffed full of sensors and batteries and wires. It looked like a rat had built a nest in there. But it worked well enough to let us prove that this stuff worked in the field, right? And again, by the time we got to the point where we were actually putting tracers on boards and building like a real physical product, we had the confidence that it was going to work.
So basically, use off-the-shelf products until you're sure, of kind of your direction, and then only then, start working on, customizing your hardware. Is that the basic?
Yeah, absolutely, man. And if you can go all the way, with off-the-shelf products, do it. There are several successful products out there based on like the Raspberry Pi, for example. They don't advertise that there's a Pi inside, but there is. So it's not as uncommon as you might think.
I mean, I'm not surprised. I mean, I've never done like commercial stuff with the Pi, but like I have a 3 Plus here, or 3B Plus, I guess. My 4s are all in my Kubernetes cluster right now, so I can't spare any of those. But the 3s. So this one, so I've done like some individual customized projects for people, like with hardware controls and stuff, but never anything on the, embedding it. I always thought like before you go to commercialization, you then go through the steps, that you guys went through of iterating and designing the custom PCBs, the custom casing and all that stuff. But actually, so we have to cover some news today.
Oh, I love the news. What news do you want to talk about?
Well, so I've been kind of talking about this for a couple weeks now, but I think it's an issue that affects all of us in the tech space. Even, no one more so than I would assume a company like yours, where you're dependent on microchips, and there's this chip shortage that's so bad that a couple weeks ago on February 24th, the White House actually put out here. I have this White House statement that basically created a commission to examine, what's going on with the lack of chips that are out there, the lack of chip supply, and then, there's like some requirements, I guess, for the study, and then they want them to focus on solutions, talk to key stakeholders. But basically, it's a presidential commission to investigate what's going on with the chips. Where are all the chips? And we know that the big guys like Tesla, even and Ford, they're having to shut down, or slow down their plants because they don't have enough auto chips. So well, first, has this affected you at all?
Well, yeah. I mean, what the first way this affected us was?
What's that?
Was actually when the pandemic started. When the pandemic first started a year ago, our whole country was almost entirely dependent on outside suppliers, on foreign countries for things like N95 masks, things like face shields, right? It got so bad even on the face shield department that a bunch of people in Birmingham joined this nationwide effort to 3D print face shields.
I saw
that because there just weren't enough, because they weren't, the demand rather spiked, and it just wasn't a product that we made in the U.S. anymore. So I'm a big believer in making things. Like pure tech and SaaS is great, but I don't think you can be a real country if you can't make your own stuff. So I fully support this. I'm really glad to see that this is happening. The chip shortage, though, yes, that has affected us actually. So we don't make a ton of stuff. We make a few thousand units a year. 10,000 would be a really good year for us. We also have some SaaS revenue streams that help offset or insulate us a little bit from shocks in the hardware pricing. But we're trying to do a production run right now, and a lot of the chips that we need. Some of them have 58-week lead times from the factory.
Wow.
Well, I mean, I can't wait a year to produce a batch of product. So, when that happens, right, you can basically try to buy surplus stock or, non-authorized distributor stock, which might be like, cut reels or leftovers from larger companies' production runs. You can wait, which isn't really a great strategy if you're trying to grow. Or you can look at a quick turn redesign. There are other products out there that have better availability. And if you're agile enough, you can go in and you can redesign the board and get that thing back out there in the market. But that comes with a whole other suite of problems, right? Now you have to rewrite firmware. You have to go in and do field testing again. Potentially, depending on what you're building, you might have to go back through FCC or CE certification.
Wow.
So it sounds like a feasible thing to say, well, maybe we can redesign the board in 4 weeks, another 4 weeks to get the firmware right. But then when you start talking about external dependencies like lab time for testing, that might tack another 8 weeks onto your schedule that you're not expecting. So for us, luckily enough, we've been able to secure a supply of chips big enough to do our next run. But we're also concurrently pursuing a board redesign to move to the next generation of chips, which are actually a lot more available. And to be honest, this is something we were going to do anyway, but the chip shortage has definitely pulled our timeline forward.
So you're saying there is no quick fix, and a chip redesign, even if you move at DevOps speed and you get it done in your 16 weeks, you still have regulatory approval as all devices. And is that because the LoRaWAN, the technology that you're using, or the Wi-Fi, or is that do all devices have to go through that?
It all depends on whether the device is like a receiver or a transmitter. It depends on how you designed it. So if you buy an RF module from a company, right, that module may carry its own certification. And if it does, then the requirements on you as somebody who's building a product based on a certified module are actually a little lower, right?
Nice.
Sometimes you can just do what's called a supplier's declaration of conformity, where you say, I'm using the module in exactly the way that the manufacturer recommends, with their antennas, with everything else. And then that really simplifies your process, your paperwork. But so yeah, it just does all depend on exactly what you're building and what you're building it with.
Very cool. All right, so I want to talk about one more thing today. So this is not really quite a news story, but it's a personal, it's a personal thing of mine. you guys, I've heard that you use LoRaWAN in your technology instead of
Hmm.
WAN, and I was looking at the Things Network, which is I guess a nationwide LoRaWAN network, and the LoRa Alliance, and so several questions. First, why did you guys choose LoRaWAN over just like a Wi-Fi connection that you could they can push to their normal hub and handle it as you would a normal, not normal, but old
Yeah.
school piece of infrastructure.
Right. Well, first of all, I want to give just a shameless plug to the Things Network. It's actually a global initiative. So thousands of gateways around the world. The U.S. is actually a little bit behind, I think. The biggest concentrations of Things Network deployments are in Europe. The Benelux countries, Germany's huge. The UK's got a pretty big footprint. We do have a Things Network community here in Birmingham. We stood that up about 2.5 years ago to start doing some testing. So the Things Network was kind of instrumental in the birth of Conserv. We built a city-scale LoRaWAN network on the Things Network here in Birmingham to test out whether we thought the technology was appropriate for our use case. And that network is still running today in support of some air quality projects and some citizen science projects. But to answer your question, we chose LoRaWAN really because our customers didn't have wireless. And when we asked them why, right? So we went to these museums. We thought for sure wireless sensors are cheap enough. We'll see them everywhere. We didn't. And we went in and we asked, well, why is that, right? Like, why don't we see, like a lot more wireless stuff out in the world? And it turns out that there were a few reasons for that. One, the battery life on Wi-Fi devices can be pretty crappy because they do have to connect, right? And they have to stay connected. If they don't stay connected, then they have to go through that whole connecting to the network and acquiring an IP address every time they come back online, right? So that chews up a lot of power. People didn't like changing batteries. Second thing is just Wi-Fi coverage in general. So a lot of these museum spaces, are huge. Some of them are literally bunkers. Like if you go to a place where they store film, for example, right? Those buildings are concrete and steel, lots of metal cabinets. Sometimes I have trouble getting Wi-Fi on the other end of my house, right? How are you going to get it to the other end of a 100,000 square foot bunker? And why would you, right? Like if there's no people in that space and there's nothing else going on there, why would you have Wi-Fi there? Same is true of like museum storage spaces, often down in the lower levels of the building. Again, concrete and steel, they're not occupied spaces, so why would there be Wi-Fi there? So that kind of got us thinking. It's like, well, how can we deliver wireless sensing products over long distances without having to ask them to put in 20 more Wi-Fi access points? And it turns out LoRaWAN is a really good answer to that. So it's a lower frequency than Wi-Fi, right? 915-ish megahertz in the United States. Very, very long range. So line of sight, we can transmit a signal, 5, 10, 15 kilometers is pretty common.
Wow.
Now indoors, of course, it's much shorter because we're passing through a bunch of walls and we get signal attenuation as we go. But the long range was basically allows us to cover a very large structure with a very small number of access points or what they call gateways. And then finally, it's such a low power protocol that we can run a device on battery for 2, 3, 4 years without an issue. So our customers are really busy; they have other things to do. So this gives them a really nice, like, super low maintenance solution to this problem.
Does the lower frequency, does that make the attenuation inside buildings, I guess, more of a problem than for Wi-Fi, or do you have?
I mean, I'm not an RF engineer, so
Neither am I.
I'm probably gonna say some wrong things here. But I think lower frequencies actually do a better job of going a long distance and getting through structures and buildings. There's also the issue that right now that spectrum, that ISM band in the U.S. is a lot less crowded, right? There's a lot less stuff that uses it. Whereas if you were looking at like a 2.4 gigahertz network, every Wi-Fi access point almost uses it. Your Bluetooth stuff uses it. So that's a very crowded spectrum, which is going to really there's a lot of noise, right? So you probably wouldn't be able to get the same performance.
So for myself, for my home system right now, planning to move back to Birmingham and looking for.
Yay!
Thank you. Happy to be back. I'm sorry that I don't know. Are you still going to be there when I get in town?
Probably, yeah.
Excellent.
Yeah. Our condo's on the market now. We're moving, but probably not until the end of summer.
Well, I'm going to be sorry to see you go, but I understand it's for Conserv, right? You're moving where your business is, and that.
Yeah, I mean, we'll see where life takes us. But so you're moving back, and what's the question?
The question is so I've been looking at different devices for my security system, and different mostly Wi-Fi based stuff, but there are a couple other protocols out there that they're low powered, and I assume the same reasons why you guys chose LoRaWAN. There are a couple for home automation that have similar use cases but at a much smaller scale. So is LoRaWAN something that would I want my home security system on that network, on the Things network? Is this something that I would really just use for sensor type things that non-security applications?
No, I mean, I think you certainly could. There are some advantages to it, right? It's a fairly secure protocol, so it does offer like end-to-end encryption on every payload that you send. As a matter of fact, that's kind of a requirement. The devices are reliable. They can run on battery for a really long time. You'd be able to cover your entire home with a single gateway, which is not necessarily true of some of the shorter range home automation protocols, which oftentimes are meshes, right? So messages have to hop from one device to another before it finally can get up to the internet. The question I guess I would have is, and I just completely lost my train of thought. Wow, that's amazing. Like I had this fully formed question in my head, and then it just evaporated.
Why wouldn't I do something standard?
Yeah, I mean, why wouldn't you just go to ADT and be like, here's some money?
So actually, I did go to ADT and I was looking at their stuff, and it's basically a Samsung Things hub with a bunch of sensors, and I'm not sure exactly if the sensors, though, what protocol they use, or if they're just Wi-Fi based sensors. Their lifetime doesn't appear to be nearly as good as yours. So I'm, that's what I don't want to happen is to have to go change Windows sensors on a regular basis. I guess that's.
Yeah, no, I get you. So LoRaWAN might be a really good fit for that. I mean, especially if you're going to move into a place where maybe you have an outbuilding, right, like a shed or something, and you want to add that to your security. If you're comfortable rolling your own, the uptime of the Things network has been pretty great. But you can also always, if you're, I mean, it sounds to me like you're running a home Kubernetes cluster, so this is not outside your wheelhouse. But you can even run the Things network stack on your own system. Like it's open source. So if you don't want all your home security messages up in the cloud, you can always just install a local copy of that on your own system and run it there. But again, I mean, I think, given that you want something reliable, maybe you'd prefer to be in AWS. I know that's an environment you're comfortable with.
Well, I mean, so there's a duality there, right? I think part of it is I do like to build my own stuff because I want to know that I can, right? So so for testing, for playing around with, I want to try the latest stuff. And I mean, part of me bringing you on here was to get, to pull information about LoRaWAN and IoT from you so I could, learn more and, play with it myself, because I think it's, as we build out our edge ecosystems, there's there's several different types of edge, right? We have the far out sensor edge, we have which may or may not have connectivity. It's it's low powered. We usually can't get our own devices in there, or if we can, they have to be small or low powered, low cost. Then we have the kind of like somewhere edge where you may have great connectivity, sometimes you may not, but you can put a device there, right? You can you have more control of of what goes there, and you can send whenever you have a connection. And then you have kind of like the near edge, which is almost like your own data center, but it's with a zero. It's not in your data center. It might be in the telecom space, or it might be. Let's see, where else could it be? Well, it could be on a ship, right, where you can put a data center on a ship, and in fact, many companies do, especially in oil and gas. But you have similar issues of connectivity, and you're measuring different things, right? So you may be measuring seismic data, so you're getting terabytes and terabytes of of calculations in, but they're small enough to where they could be sent over LoRaWAN or something like that. Where I think you were telling me when we were doing tech check, 16 bytes, right? Is that the size of a message?
It depends on which spread factor you're on and all that kind of stuff. But I think in the U.S. it can be as low as 11 bytes.
Oh.
Yeah.
So how much data can you really pack in 11 bytes? I mean, that's my last name won't fit in 11 bytes.
Well, I mean, if you're clever with little bit packing, you can get a lot in there. So we have an 11 byte payload. We use that to send temperature, relative humidity, an ultraviolet index value, an infrared measurement, and a visible illuminance value. And we're able to get all that into 11 bytes with sufficient precision to be useful. So,
that's pretty incredible.
I mean, we can't send data at the precision that our sensor is able to collect it, because that would just be too much. But to be honest with you, like the precision at which the sensor can collect isn't really all that important. Like who cares if we have relative humidity out to 8 decimal points when the sensor is only accurate to plus or minus 2%, right? Like in many ways, the precision is kind of absurd. So sometimes you'll have to truncate things, but you can fit more in there than you might think.
Very cool. Well, it's time for you to give us a book, to give us something to set this week going. And do you have a recommendation for us to read or to listen to?
Yeah, I do, man. I do. How Not to Be Wrong by Jordan Ellenberg. Yeah, this is one of those books that I picked up in an airport because it just looked interesting. I was on a business trip. I was like, oh, this looks fun. So I just kind of grabbed it. I've actually reread it a couple of times since then. And it's basically just about all the ways that statistics and math can mislead you. Like it's really great because once you finish this thing, you start looking at the way that people use statistics and you're like, wait a minute, this is just wrong. Like they're actually manipulating the way they talk about statistics to make a point, but that's not what the numbers are actually saying. So it starts off with this story that's been told 1,000 times about aircraft coming back from World War II, and they count all the bullet holes in all these planes, and they say, okay, we've got all this data from thousands and thousands of sorties, and here's where the planes get shot. So they take all this data, like these maps of the planes with all the little bullet holes in the map, and they take it to the statistician and they say, dude, where should we put the armor on these planes so that they don't get shot down as easily? And the guy, I don't even think he looked at the data, right? I think he just said, well, this is easy. You put the armor where the bullet holes aren't, because the ones that get shot there don't make it back to be counted, right? So it's kind of it's like the classic example of survivor bias, right? If you're only counting the survivors, you're going to miss like a huge percentage of the picture. So anyway, the book is full of stories like that, and it's not so math heavy that if you're math phobic, you'll immediately run for the hills. But it's really great for just helping you level up your bullshit detector. Right.
All right. It's on my list. Yeah, and I wouldn't say I'm math phobic. I'm just math light. This is what I prefer. But this looks excellent.
Well, I didn't come to love math until I was in my 40s. I never really hated it, but I never really loved it either. And in the last 5 or 6 years, I've just been like, oh, okay, I get it now. Like it's later in life, but it just all clicked.
You found its importance.
Yeah, it's for more than just budgets.
Very true. Well, thanks for joining me. I would like to just take a minute to wish the world a happy or a equally awesome International Women's Day.
Oh, it is International Women's Day. Hooray!
Yep. Which is pretty cool. I have a lot of women to be thankful for. Not least of which my mom, who used to always tell me, if you don't amount to anything, you'll be a programmer. She taught me well.
Yeah. So what did she want you to be? Like a doctor or a lawyer? An engineer. Engineer won't get you disinvited from family functions, but it might.
It won't get me disinvited, but it won't get me talked about. So
That's right.
it won't get special mention. But Nathan, thank you so much for joining me, man. I hope you have an awesome week, and I wish you and Conserv luck in 2021. And you know, is there anything you want to tell us before we head out?
No, man. Thanks for having me on this morning. Like, I'm pumped. I'm ready to get my day going.
Awesome, man. Thank you. Me too. Have an awesome week, everyone.
You too. Cheers, man.